All right, so let's look at another example. We're going to have to solve for a missing angle. So let's go ahead and follow the same steps. We're going to label the sides and then figure out what's given and what we need, and then we're going to identify a trig ratio. So let's see here. So we've got, so I'm given here, we can label the hypotenuse really quick. So we know which one's the hypotenuse. This is automatically going to be my hypotenuse. We know that the side opposite the angle is going to be this guy right here, which means that 12 is going to have to be the adjacent side. There we go, perfect. All right, so let's see, what are we given and what do we have here? So we're given the 12, right? So I'm given the side 12 and I'm given the 15. So what trig function has the adjacent and the hypotenuse? Right, so we want to start getting better at this. Right, we're looking at SOHCAHTOA here, and what has the A and H here? So A and H, that's got to be cosine. So we're going to use cosine here. So the cosine of my angle X, I don't know what it is equal to the opposite, I'm sorry, it's equal to the adjacent side over the hypotenuse side. So we're going to go ahead and apply the inverse. All right, remember how the inverse works. We're just going to swap them. The x now goes on the outside, and then the 12 over 15 is now going to go on the inside of the inverse. And now I'm just going to plug that into the calculator. So my cosine inverse, so second cosine gives me 12 divided by 15. I'm sorry, it's I plug in 12 over 15 into the cosine inverse, and I get 36.869, which is 870. And there we go. Okay, so in this example, we're going to want to find all the sides and all of the angles in the triangle. So the way we're going to go ahead and label these is, first we got to identify what we already have, right? We already have angle S. So angle S is going to be 90 degrees, right? That's already given to me. We already have the side opposite angle S, which is also S, so that's 36. And then I'm also given the side opposite angle T, which is side T, and that's going to be 19. So our goal here is all we need to do is we need to solve for side R. We need to solve for angle T and then angle R. So let's go ahead and let's start with our first one. Let's see. Let's pick something to solve for first. We could solve for side R. Let's solve for side R first. This will be a good spot. Let's put it right here. So for side R, the way we can solve this is, if you notice, we're given two sides of the triangle, right? So this is a right triangle. Whenever I'm given two sides, I can automatically use the Pythagorean theorem. So I can do 19 squared plus, I can do 19 squared plus r squared is equal to 36 squared. So let's go ahead and plug that into my calculator. Now I'm going to end up with r squared equals 935. Let's see if we can simplify this. So it can definitely be divided by 5. So I end up with 5, right? We're going to square root this. So 935 can break up to be 5 times 187. Let me see if 187 can be divided by anything. I think 187 might be prime. Yeah, I can't find anything to divide into 187. So, oh yeah, 17. 17 and 11. But both of those are prime numbers, so I still don't have any pairs. So no pairs here. So we're just going to leave it as the square root of 935. All right, so side R, is now equal to the square root of 935. So 935. So square root of 935. All right, perfect. So now I want to go ahead and solve for my angles, right? Let's solve for let's solve for angle R. Since we got side R, let's solve for angle R here. So for angle R, notice what we're given, right? We're given all the sides. So we can use our inverse trig functions to find the angle. So I'm gonna use whatever's given to me, right? I was given this side and I was given this side. So if we label this, this is the hypotenuse, this is gonna be your adjacent, and then this is the opposite side, right? So angle R, in order to solve this, we're going to need the adjacent side, right? I'm given the adjacent and the hypotenuse, so that's cosine. So I'm going to use cosine. I'm going to say the cosine of angle R is equal to the adjacent side, which is 19. Sorry, let me get that a little smaller, which is 19, divided by the hypotenuse, which is 36. We're going to go ahead and inverse this. Remember how we do the inverse? So the angle comes outside, and then it's equal to the inverse of 19 over 36. Right? I swapped their positions, right? Remember we just swapped these two. All right, and now we just plug that into our calculator. So 19 divided by 36, and that gives me 58.144. Done. So I have angle R. So 58.144. Whoops, let me zoom in. It is looking really messy. 58.144. Okay. Now I need to find the last angle here, which is going to be angle T. We have some space for angle T down here. Okay, so we're gonna have to rewrite our we're gonna have to relabel the sides. So the adjacent and opposite are now gonna change because I'm now looking from angle T. All right, so this is good. I'm still given these two sides. So let's see. Now this is going to be, now the 19 is going to be my opposite side, and now the R equals square root of 935 is going to be my adjacent side. But again, I'm going to use what was given to me. I was given the hypotenuse and I was given the opposite. So O and H, that's sine. So to find angle T, I'm going to use the sine. Sine of angle T is equal to the opposite side, 19, divided by the hypotenuse, which is 36. Then I'm going to go ahead and do the inverse. So T is equal to the sine inverse of 19 over 36. Plug that into the calculator. And then that's going to give me 31.855 degrees. There's our right triangle. And let's see, what could we put here? It says a certain part of a hiking trail slopes upward at about 5 degrees. So usually when they give you an angle, let's put that angle, we can typically just put it here, right? So we're going to call this angle 5 degrees. Right, that's what we're given. Right, and it makes sense, right? It's hiking trail is sloping upward, so we know it's going up. So after traveling a horizontal distance of 100 feet, so whenever you see like vertical or horizontal distance, that is meaning the legs of the triangle, right? So in this case, they're saying that this is 100 feet. Oh, excuse me. So they're saying this is going to be 100 feet horizontally. If they just said he walked 100 feet along this path, then they would have meant the hypotenuse. So let me just add that right angle there. So then it says, what would be the change in a hiker's vertical position? So whenever they say vertical, right, that's meaning one of the legs. So that's going to be this leg X. And then it's saying, what distance has the hiker traveled along the path? So it wants to know its vertical height, and it wants to know how far did he travel on the path. So it wants to also know the hypotenuse. So we're going to have we're going to have to solve for two variables here, so we're going to get two equations. Let's go ahead and create our first equation. So our first equation is going to be to solve for the x. So let's look at what's given, right? I'm given the horizontal distance here is 100. And I want to find this side x. So let's go ahead and label our sides. We know this is the hypotenuse. I know this is going to be the opposite, and this is the adjacent. So what uses opposite and adjacent? Well, that has to be tangent. I'm sorry, tangent. All right. So my tangent we can get a little closer actually. Let's put it right here. My tangent oops, there it goes. Okay, so my tangent of my angle 5 degrees is equal to the opposite side divided by the adjacent side. So now we have to go ahead and cross multiply. So let's divide each side by 1, cross multiply, cross multiply. So I'm going to end up with x equals 100 times the tangent of 5 degrees. I'm going to go ahead and plug that into my calculator. So I get 100 times the tangent of 5 degrees, and I end up getting 8.748. Alright, so now I have to solve for y. So now I'm going to change this up a little bit. So this is going to go away. Whoops, I didn't want to erase the triangle, but okay, we'll fix that. There we go. So now I want to solve for the hypotenuse. So I have the adjacent and I want the hypotenuse. So a and y. So what is that going to be? That's going to have to be the cosine, right? So I'm going to create the cosine of 5 degrees is equal to the adjacent side, which is 100, over the hypotenuse, which is my variable y. And now we can go ahead and put a 1 under here, and then I can cross multiply. So then I get 1 times 100 equals y times the cosine of 5 degrees. Now I can divide by the cosine of 5 degrees. Right, divide by the cosine of 5 degrees. Same thing on the other side. And go ahead and plug this into your calculator. 1 times 100, what's 1 times 100? That's 100. Then divided by the cosine of 5. And I got 100.382. Right, 0.382. Whoops. We'll just leave it like that. 100.382. Alrighty, and there we go.